Welcome to day 4 of 30 days of AL, and today we are going to look at the facade design pattern.
Hii ni Tech na Msangi ya jishinde.com.
And the facade pattern is a software design pattern commonly used in object-oriented programming and analogous to a facade in architecture. A facade is an object that serves as a front-facing interface, masking more complex underlying or structural code. So a facade can improve the readability and usability of a software library by masking interaction with more complex components behind a single and often simplified API. So it provides a context-specific interface to more generic functionality, and then serves as a launching point for a broader refactor of monolithic or tightly coupled systems in favor of more loosely coupled code. So developers often use the facade design pattern when a system is very complex or difficult to understand because the system has many interdependent classes or because its source code is unavailable. So this pattern hides the complexities of a larger system and provides a simpler interface to the client. It typically involves a single wrapper class that contains a set of members required by the client. So these members access the system on behalf of the facade client and hide the implementation details. So basically, it's a very simple design pattern where when the system becomes more and more complex, you have a wrapper class that only displays whatever is needed and the complexities of the system are hidden. And again, when you come to now Business Central, so this pattern is to provide a unified API to a single or a collection of potentially complex subsystems. So if you apply this pattern as a general pattern, you will will ensure improved decoupling, encapsulation, readability, testability, maintainability, and whenever you want to write an isolated piece of business logic, from now on refer to a subsystem, this pattern should be applicable. So the two problems that it addresses, so when a system grows, it becomes more complex, as Wikipedia has explained. And so an object or method which is publicly accessible may not receive breaking changes in future. So releases without announced releases without announced deprecation. So this complicates maintainability of the system. By adding a facade, you ensure the subsystem is inaccessible to the outside system, enabling you to change implementation details of the subsystem at will. So if you would like to change the implementation details of a subsystem, then you implement a facade. You only display to the user what they can see. So anything that is inside in terms of maybe the details and the complexity of the systems, with time it can change, but to the user side nothing changes. They are just seeing whatever they need to use or the methods that are exposed to them for them to implement. So when a system becomes more and more complex, you implement a facade. So the system application in Business Central has a sample or a facade implemented in a way. So similar, I've used the Temp Blob code unit 4100. So this Temp Blob has a Temp Blob implementation. So this is the facade that is displaying the implementation details. That you can see the access is public, but for this one, the access is internal. So access to what we the users access when we are doing when we are creating in streams and out streams, or when we what was the template for when we want to implement the in-stream and out-stream, because it encapsulates the implementations of in-stream and out-stream. we use this code unit. But if you go to the code of the temp blob, if you are creating an in-stream, the implementation is done by the temp blob implementation. So most of the system subsystems or system code units and methods have implemented this design pattern. So like the create in-stream will call the temp blob implementation dot create in-stream. So whatever we have is this. So the part of the temp blob implementation can change. So this part can change the create in-stream from this side, but as long as we get an output of an in-stream, then for us we're okay, because on this side when you create an in-stream and you want to read values from the blob content, then we get now the implementation, which is the temp blob create in-stream again, and then it takes in the in-stream, which is passed in as a reference from this side. So if your system is growing more and more complex and you have algorithms maybe specific to things like tax calculation, things like what else can I think of quickly? Anything that you know is you don't want it exposed to outside the implementation, then you use the wrapper class, which will be a code unit now, and then the implementation details will be hidden. So that's it for day 4 of 30 days of AL. I will see you in day 5 of 30 days of AL. So see you there.
If you enjoyed this video, make sure to like, subscribe, and ring the notification bell so that you don't miss the next one.